Hello and welcome to this episode of Innovation 2020, a series of short presentations about innovation and teaching in the College of Education at the University of Georgia. I'm Lloyd Reber, a professor in the Learning, Design, and Technology program and Director of Innovation in Teaching and Technology for the college. In these episodes, we showcase ways in which instructors in our college are creative and innovative in their teaching, often using existing and emerging technology in new and interesting ways. Besides recognizing the innovation already being practiced by our college's faculty and instructors, we hope that these creative ideas and strategies will motivate and inspire others to take risks in their teaching and to take full advantage of the affordances of technology.
Thank you, everybody, for coming to see me talk. I'm Jonathan Templin from the Department of Educational Psychology and Instructional Technology here at Georgia. I'm part of the Research, Evaluation, Measurement, and Statistics program. I teach statistics courses to doctoral students for the most part, although I have taught a few master's students now and again. And I'm here to talk about my teaching philosophy and how I integrate technology with teaching and what I've come to learn in the years I've taught statistics from all the way back when I was an undergraduate all the way up till now. I think in short, I'm just going to say I have a real passion for the subject. I love statistics, I love teaching, and I kind of go crazy in front of class sometimes. I really enjoy it. It's a kick to be in front of people. So that might happen a little bit here today, and I don't mean to scare you. At least it's like the Sea World where you have those seats at the front where a Shamu might get you wet. That might be. I'm trying not to spill the water on you. Anyway. So overall, my philosophy about teaching statistics stems from the thought that learning statistics at a high level is like learning a new language. People have to do a lot of translation to get to what you're doing. It's not just about concepts and overall big picture. It's also about details that get caught up in mathematics. And it is not mathematics. It's not like taking a math course because there is a lot of kind of trial and error to statistics. The overall use of statistics is essentially trying to form a set of pieces of evidence for or against hypotheses you may have to help describe the world a little better. But getting to that point and doing so effectively is less like looking things up in a cookbook and more, I think, about trying to kind of know the nuances of a language. And so that's really where I begin my teaching philosophy. Another thing I've learned about statistics courses is they're very diverse in terms of the audience. And there's quite a few problems you have to recognize ahead of time potential problems, I should say, before you actually start teaching. So the first thing, the background of your students. You'll have people from all different walks of life in your class. In the class I'm teaching currently, I have students who are very technically minded with math degrees in the Department of Statistics, and I have students who are social work people, who probably, who are also very bright, but just aren't as trained in mathematics. And how you walk a fine line to make sure that people who are sophisticated in math, but maybe not sophisticated, while trying to get them to understand the same subject can be somewhat of a challenge. Furthermore, each of the statistics courses we teach here and in most places kind of have a curriculum, and so you have a series of prerequisites. And not everybody kind of subscribes to the same teaching philosophy or theorem. There's really no curriculum, so to speak, particularly in most of the PhD programs. And so you have not only a difference in background, you have a difference in kind of learning experience as well. Here at Georgia, we have a little bit of an issue in that we have typically large numbers of students who want to take our courses. So currently my course, I think, has 32 officially enrolled, but I think somewhere around the lines of 40 to 45 show up each week to hear material. And believe me, if people who are volunteering their time every week show up to be there, it is, I feel committed to trying to teach everybody who's there, regardless of whether or not they're officially enrolled or not. That also becomes a problem a little bit when you start building a course and trying to understand how to evaluate students or the type of work that you want to give them in terms of the level of depth, because you can't really spend a lot of time grading 32 assignments in detail. It becomes a lot more difficult. a lot of problems that we have with statistics is that we teach things compartmentalized. And we're going to talk about, I'm going to talk about this a little bit later, but I think we've, as the discipline of statistics in education or in psychology or in the social sciences has evolved, we've kind of learned things in chunks. And our curriculum kind of mirrors that. We teach analysis of variance, we teach regression, we teach structural equation modeling, we teach item response theory, rather than teaching kind of the generality across everything. And I really actually think there are about 4 things that you need to know about statistics to be able to do about 95% of the methods out there. Now, those 4 things may take you 2 years to cover all of, but if you take it from that perspective, I think you'll have a lot more shared strength rather than compartmentalizing. And I'm in analysis of variance now, but next year's regression, and which one am I going to use for my analysis? It's have a little bit more big picture. Another issue that comes up in our classes is motivation. So I'm not too familiar with other disciplines, and I'm sure there's a little bit of this in each of them, but I feel like a salesman the first day of class. Why do you want to take this class, and why do you want to use these methods? Why do you want to know about it? You almost have to motivate people to do this because a lot of the material is so abstract at the beginning, at least for the way I teach. It takes a lot of patience to get through, and as soon as you get through kind of the foundation, then it all starts to come together. That's the good part. But really motivating. Particularly in the introductory classes, we have people who are forced to be there, who may not want to be there at all. When you get into the elective classes, motivation's less of a problem. The other issue is that each person wants a different level of knowledge. So we'll have students in our program, in our courses, and they'll want to learn everything there is to know about whatever topic you're teaching. And then you'll have a few other students, they want to know only what they need to know about their dissertation. So how do you try to integrate each of those together? It's a problem. But I think what it all comes down to, when you start teaching the statistics, you start teaching the language of statistics, or you think about it from this language perspective, what you're coming up against for each person is cognition and the limits of which people can actually listen to you and keep track of stuff throughout the entire lecture or through readings or however. And so you have to remember this as you teach. And so everything that I do tries to make it so that the cognitive load of a person is somewhat minimized. Even though we get through some really hairy stuff, I try to keep it in a way that's repetitive, even if it's somewhat new, it's still repetitive, or it builds off of, and there's a kind of an overall point to what's happening, just so as working memory can help you to remember, when you get to a certain new part, you won't have to struggle to remember exactly what each term is. Perhaps it'll be a little bit more familiar. So really what we're dealing with is motivation and then like the human limits of cognition. So that's the issues that I think about tackling when I do teach statistics. What you're about to see in just a little bit is how I try to do it using technology, using online tools to try to overcome those. But just a little bit more about kind of the core of where I teach from. I mentioned previously that I thought about 95% of the statistical methods that you'll do could be covered in basically 4 big topic areas. And that's how I try to approach it. First big topic area, linear models. These are things that include analysis of variance, regression, basically anything that has like a line trying to predict stuff. They happen all the time. Second is link functions, or categorical or non-continuous data. So what do you do if you have a binary observation? It's a 0 or a 1. Or what do you do if it's a count? What do you do if it's not exactly a count? Maybe there's a lot of zeros to it. How do you combine number 1 with number 2? Right? The third is the inclusion of, or the types of data that you have that may have additional dependencies. So if you have data from the same person, they tend to be correlated. Or people in the same classroom, they tend to be correlated. And statistically, what we end up doing to try to modify this is we include things that are called random effects, or if you're doing measurement, those would be latent variables. They're essentially one and the same. It's just a matter of trying to make certain assumptions about people and have those assumptions filter through to your observations. And finally, because this is kind of where I come from, I believe you know a little bit about estimation to be able to put it all together. So that way you can believe the numbers that come from the computer or however you're computing these. If you have all of those four, if you kind of reinforce all four of those, I really believe you could build a statistics curriculum around that. And so if we were to think about redesigning our curriculum here or elsewhere, it would really emphasize these four topics because you can cover most of what's out there with it. And I say what's out there, it's popular methods. There's a few other ones that you can throw on top of this that would add to kind of get to 100%, but I think that's the four core things. And I think about it, but I really believe that if you think about teaching statistics in compartmental components, so analysis, variance versus regression, let's say, in each class, people think they're kind of starting from the beginning. They're starting over. When in reality, each of these is kind of expanding knowledge rather than starting over. And so if you taught it from a general perspective, or you try to link methodology to other methods, you could build upon a knowledge base that's already there. You can people will start with something. So for instance, I'm teaching structural equation modeling. I can't even say the topic. How can I teach it, right? I'm teaching that this semester, and I start with regression because, okay, people have taken regression. This is where we go from, and then we expand from there. It's that generality is where the strength happens. And through generality, you can get repetition. And repetition helps with memory, right? And so if you're talking about, okay, what we're doing is regression, but we're now adding in this new type of term to it. It turns out that it's a factor, and all of a sudden you've got factor analysis. Or better yet, we're doing this regression, and we have multiple types of equations simultaneously. All of a sudden, you're in path analysis, right? So you've got a lot of things that people have seen before, and a lot of things that are familiar with which to work. And from there, you can build and go into more technical details beyond which scratch the surface of the superficial. So, in my opinion, my goal is to train people who are not just technicians, people who are not just, I'm going to go run my favorite stat package and interpret the output. I want them to know a little bit more underneath the hood because these are the people who are going to be our journal editors, our peer review personnel out there. They're the last line of defense between quality methods, quality science, and things that are not so strong. And I feel like having a little bit more depth of knowledge allows them to be a better reviewer, a better consumer, a better scientist. And that's what doesn't come about from just essentially looking at output, I think. So that's problems, kind of the overall where I could start from as a base. And here's how I do what I do. I'm going to just talk a little bit about my course structure, which has really been forged over the years through trial and error. I've taught for a while. My first class was 1998. I was 21. I was actually the youngest person in the room teaching the stat class as an undergrad. It was kind of fun. But believe me, it was terrible, right? And now I'm no longer the youngest person in the room. I'd like to say I've learned a few things. Each of my lectures, it's somewhat difficult with a new prep, but each of my lectures I try to have a series of unique lecture slides. Okay, so I'd like to talk a little bit about my course structure, which is built along the ideas of where I've kind of encountered problems, but also my general philosophy of trying to link things together. So the first thing that I try to do every week, which is somewhat difficult with a new prep, but is to build a comprehensive set of lecture slides. So in my slides, I try not to avoid the technical material. So for instance, up here is my website for structural equation modeling, and week 2 is matrix algebra. I don't want to go around that because I feel there's a lot of material in structural equation modeling that requires at least a cursory knowledge of matrix algebra to see an equation and understand what's going on a surface level. So I'm able to put, with PowerPoint, equations in. I love the new PowerPoint equation editor, by the way. It's fantastic. But also graphics. And I know there's a saying, a picture says 1,000 words. And so I kind of had this thought, whenever I put an equation up, which by the way for continuous real valued numbers says an infinite number of words, the picture with it puts it into a little bit better language. So we talk about statistics as a language. The language is a lot of equations. The language is a lot of shorthand. And so when you were in a regression class, you saw y is equal to some intercept plus some slope times x plus error. That was your first introduction to it. When you get into matrix algebra, it's like that on steroids, right? You see a lot of y's, a lot of x's, a lot of things going on, but it's a shorthand. There are even some people who would argue that statistics, modern statistics as it is, was aided by the, kind of the notational conveniences of matrix algebra. And until that came along, it was not able to actually move forward in statistics because it was so cumbersome to look through all that detail. So that being in mind, I try to, whenever there's an equation, I try to bring a picture with it to try to link it. So not everybody thinks in equations, but that's where the heart of everything works. It's how the computer works. It's how it works. It's the language. So my lectures have these slides, equations, example output, trying to link everything to build together. But a lot of times I've heard people say, I wish, they're trying to take notes on slides. I wish I could just hear that again. Well, I try to, so long as it works, record my lectures. And I have MP3s available on my website. So people can listen to me podcast talking about statistics. In fact, I was went to the Ramsey today. I was going down to the locker room and I ran past a student of mine. I said, hey, this is weird. I was just listening to you this morning. So it's something that, you can go back. If you didn't quite get a certain concept, you can try to listen to it again. Because again, if you're learning a new language and you're kind of getting an immersion treatment, catching up is sometimes impossible, even if the teacher is trying to go a little bit slower. So that's my thought. I'm trying to make it accessible. I'm trying to make it where you can get a hold of these MP3s. And they're online. In fact, I try to archive all my materials on my website so that if you were a student of that class and you go off and you start doing great things, but you wanted to remember one lecture or whatever, you can still come back and find it. So the website has MP3s of me telling terrible jokes back in like 2007 or even before. This is just kind of that philosophy where you can come back and try to remember what was happening. To that note, I try to give homework assignments that are built off of the computer programs that we use for statistics. I don't like doing anything by hand for the most part. These homeworks tend to come every week, and that, depending on the size of the course, really is where I am able to teach a lot more. So last semester I had a smaller course. It was multivariate. I gave out homeworks where I try to allow people to have a revision. So every week they'd have a homework due. I would grade it. I would have them do writing. I would have them do whatever. I would critique their writing. I would critique their methodology, and then they could revise it. What that allowed me to do was ask a lot harder questions because they could fail. And they could learn from their mistakes and fix it, and then get full credit for the assignments. And so I had students, I was trying to get people to understand this concept of what a multivariate distribution would be, a multivariate normal, which is a very abstract concept, particularly when you're not used to that. And they were working with matrix algebra and this distribution and in SAS, and it was very abstract, but as soon as we started going down the class, it kind of laid the foundation for understanding multivariate analyses, which was the topic of the course. That wouldn't have been possible if I couldn't give them a chance to have feedback on their homework and try a trial, essentially. Okay, this didn't work out. This is how you fix it. With a larger class, that's not easy to do. So I'm not able to work that this semester, although I think there'd be a great method, a great way of doing so if I could integrate a lot of homework based on online, enter your answers online, and it won't let you continue until you get the right answer. And so essentially you have your own trial and error, and then at the end of that you have to write a paragraph or two results section, and then I get to grade that and critique your writing. But I haven't worked that in yet. Another thing that I do is I try to make it so that class shows up in people's conscience all the time. And we have e-learning commons here, and there's discussion boards, but pretty much everybody's got Facebook. And so what I do is I have a Facebook page for my class, and I force them to like it. I know it sounds terrible, but they get credit for it. But that way, if I post something, I show up in their on their thread. So if they're on Facebook more than they're doing statistics, which pretty much everybody is, and I do statistics for a living, and I'm almost there, right? It reminds them, or it shows them. But it also allows people to post questions, and I can announce comments to it. Or I've held online office hours on Facebook before, where I sign in, and I'm chatting with 6 people all at once. So it really allows for kind of a direct access that kind of the intent of what a lot of the course management systems do, but in a much more effective way, I think. I put my course, speaking of course management, the other thing I do is I put my course materials on Dropbox. So everybody has a Dropbox folder, which automatically syncs. I have a shared folder which I sync my material with. So if I drop a new assignment in or I drop a new reading, it shows up on their computer, and they can just open it up and read it. This is something that, again, allows me to communicate with them a little bit more frequently and a little bit easier than in the course management systems that we have. I don't believe in giving out question and answer tests. I don't think that's something that the type of knowledge I don't believe statistics should be timed. I know it's, we can have debates about that throughout pretty much time about almost any topic about that, but my philosophy is it's better to think through a problem fully rather than try to think on the fly. And finally, what I try to do is to have access. So we only have so many hours in class. And you have to teach the language of statistics, but then you have to teach the practice, understanding the computer syntax. So I try to, this is the dilemma I've always had is how much time in class do I devote to talking about syntax, when really, you can talk about a statistical method abstract from the software you use to implement it. So I've gotten this semester, I've gotten in the habit of holding office hours in the computer lab. And so I'll try to assign a homework, and rather than have to spend class time on talking about syntax, I will have an opportunity for people to come find me and talk to me in the computer lab once a week, or find me outside of class if needed, if they can't make that time. So I find that that's a little bit more effective balance, because I really do feel like it's one of those necessary evils. You have to spend time of instruction on human-computer interface, but that's not the point of your course, right? The point of your course is statistical methodology, which really, you pick a software program, you've got a new interface to deal with. So my latest attempt to try to overcome that is to try to rely a lot on independent learning for students. There's a lot of online help for each software package, but then be available in office hours for the specifics versus spending course time on it. Finally, just 2 more things that I like to do. Number 1, I like to try to make the content somewhat engaging, so I try to find articles that are recent. And my examples are usually based off of these articles, so I'll simulate data which will behave, and then I will hand out the article as well. It's my way of trying to get people to see the practice a little bit more, so how people report on certain results or how people analyze certain things. And I also like to try to encourage questions as much as possible. I know statistics is one of those intimidating topics where if you don't get it, you feel ridiculous. But as soon as you do get it, it's obvious. It's clear, right? Oh, well, how did you get that? It was easy. It took me 3 weeks, but it was easy, right? And so it's that type of it's okay. There's really no way, trying to be accessible, and if you're not comfortable in class, I try to allow people to ask me questions online or in email or however they can find me, just so they can get access to it, because it really is there's a lot of time outside of class that's needed to be able to do this. So that's kind of my overview of why I teach the way I do, how I try to integrate technology with teaching, how do I try to avoid it sometimes, but that's only the computer interface, and how I've come to so far to teach statistics courses. Now I know I have a lot to learn, so but that's kind of it to now. So thank you for your attendance. I really appreciate it, and I look forward to our discussion.